meeting is being recorded.
I'm just going to mute everybody.
Just give me a second, Bobby.
All right.
Righto.
Very well.
Welcome, everyone. We're slowly getting a few people in. So we've got 23. Okay. How are we looking? So still got 23, 18:02. We are recording, everyone. And I think we'll just get underway. You let them in, Bobby, if they come in.
Yep.
Very good. Okay, I think we'll just get underway. Well, welcome, everyone. My name's Michael Forbes, President New South Wales AFI, and welcome to the April Education Night. Tonight, we're great to have an old work colleague of mine, Anthony Wallgate. Anthony's been with Fire Rescue since the late 90s, but he started off his career in fire rescue as a retained firefighter in the early 90s in Deniliquin, and then joined Permanents in 1997. Is that right?
Yep, correct.
Yeah, 1997. He went to a few stations before coming over to Hazmat, and that's where we sort of met up, working on the same shift for a couple of years. Wally then went off to look at and become an aviation officer when Fire Rescue had a joint helicopter use with New South Wales Police, and he was one of two aviation officers working there for a number of years. I think that gig got a bit too expensive for Fire Rescue to maintain their budgets, so they looked at a different capability, and that capability was RPAS, which is the remote pilot aircraft systems. He took that on and was there from the start, and has applied and got the job as the chief remote pilot, and he has been doing that since they transitioned away from the helicopter. So tonight, Wally is going to give a presentation just around RPAS. It's not focused on fire investigation. We have had a presentation a few years ago around RPAS and fire investigation. But yeah, someone sort of mentioned to me that what's going on with RPAS these days, and the only way to find out is to actually go to Wally from a fire rescue's perspective, because he knows exactly what's going on, and certainly what is the future, I think, is what a lot of people are interested in. So just a reminder for people, if you've got a question or something, just put it in the presentation as we go through, and I'll just interrupt Wally to ask any questions you have. Try and keep your microphones on mute, and I'm sure there's going to be plenty of time at the end for questions. So without ado, Anthony, go for it.
All right, thanks, Michael, and thanks everyone for inviting me along. It's very nice to be invited to these presentations and actually spruik what fire and rescue and how their RPAS capabilities come along. So when I look back at and my PowerPoint has stopped working, so which is off to a good yes. Yeah, so that's locked up, Michael.
Oh dear. What do you want to try and exit?
Hang
and
on, let me see
okay.
if I can. Stand by. Sorry, mate.
That's all right.
Apologies. Technical issues is always the thing. And we do get these with RPAS as well.
There you go. While he's going at that, I want to talk quickly about our next education night. I don't know if Mark Pellegrino is on, but he will certainly, if he is, have a chat to us at the end. The next education is going to be interactive. So it's going to require you to actually do a training course through Underwriters Laboratory. And then one of the main researchers over there is going to give a presentation after you've done that. So look out for that. That's going to be in June. But anyway, while he's back, yes, and we are working. Go for it.
All right. So basically, I'll go through basically the history, the RPAS capabilities, how we can benefit or how we benefit fire and rescue, and also the other agencies. What we found by when we first started off with the RPAS, it was integrated into fire and rescue, and we're doing a lot of work with that. But we also found that a lot of other emergency services and a lot of the government agencies started using that capability as well. The response, where we're going, and the future potential within fire and rescue, and also other agencies that we've been utilised. So when we look at like RPAS and how it's come about with us, we started off in around about 2014. We were after we lost the helicopter or the rotary wing asset that we were using with New South Wales Police, we started looking at other opportunities, and one of them that come up was RPAS or drones at that stage. And back in 2014, there was a lot of different products that were on the market compared to what there is today. So what our smallest RPAS that we use today, back then was worth around about the $80,000 mark, and it could only fly for around about 6 to 8 minutes in its total flight. Its camera was a standard definition. There was also fixed wing that we looked at as well. And then as technology caught up and DJI products that come out, and a lot of different other companies that actually bought the different types of RPAS out, we started looking at it. Around about the 2014, 2015, we bought 6 types of RPAS. And from then, it's just been a growth to where we are now in 2022. We were very lucky in 2019, 2020, after the bushfires, to be actually given a large sum of money from the state government that's actually enhanced our capability to what it is today. So when we look up our basic setup, for us, I'm attached to the bushfire and aviation unit within Fire and Rescue New South Wales. So we have our chief superintendent, which is Jeremy Stubbs. He looks after technical capability. Then I'll have my manager, Superintendent Scott Donoghue, my team leader, which is Ryan Niche. Then we have 4 technical operation officers, which are aviation based, and we have 4 relievers as well, and we have 2 GIS analysts, which are integral to the getting all of our mapping as a whole unit sort of thing. In the early days, there was only 2 of us to start off with. We had no team leader. We're sort of orphaned, but as it started morphing into once we started getting into the RPAS in what it was. And back in 2014, when we actually first bought they were the old Inspire ones, we decided early to look at the research and development. So that's when we went to Michael at FIRU. We went to a few other different units, bushfire, rescue, hazmat, just to see how RPAS would integrate within fire and rescue, and start off from there. And what started off as something that was probably this big ended up something that's grown exponentially to where we are now. And that is what you see on the screen now. So we've got close to 91 RPAS platforms now, over 200 pilots. So we have 91 multi-rotors. We are looking and about to purchase our VTOL or powerlift fixed wings. We've got sensors from our normal RGB cameras, thermal cameras, multispectral cameras, LiDAR, hyperspectral and ground penetrating radar that are all about to be purchased from the business case that we got from the New South Wales government, and that money was around $5.2 million. So we're just finishing this financial year, rolling all that capability out. You can see the hours of research, around 46,000 hours. Now, one of the biggest things that we found early on was the amount of data, and as in whether it's photographs, videos, where that's actually stored and how much there is. So just think of when we first started, around 6 or 7 RPAS. Now we've got close to 91. All of those RPAS units are actually taking photos, taking videos. The LiDAR takes like gigabytes and megabytes of data that actually has to be stored somewhere. So we started off early in the inception of this to actually set up like storage devices and where that's all stored now. A lot of our data is glaciated, so we can actually cold storage it, and then if it need be, pull it back up for any type of, if it goes to coroner's court or we're pulled into any sort of capability management meetings, all that sort of thing. So one thing I do stress, if you are looking at getting into this, set up your storage and your data very, very early, because there is a lot of it. And when we looked at the potential for this, and it's infinite, it is just growing exponentially each year. For every time we buy a new platform, there is always something coming out within 3 to 6 months later, sort of thing. And everything now is becoming quite smaller. So we just trialed out one of the new Mavic Matrice 30s, and basically our basic work platform is the Matrice 300 at the moment. So everything it's getting on that is miniaturized on the new one, and the technology's catching up a lot quicker than basically we can keep up with it. So early on in the onset of that, also we set up our management of RPAS, and actually when do we get rid of them or dispose of them, and that's between 2 to 3 years. That's the only way we can keep up with the technology that's moving along that quick and everything like that. Otherwise, you're left with outdated technology, and you're behind the 8 ball straight away. Just try and catch up with it. These are some of the jobs that we've gone to within the different types of government agencies, and basically we've ticked all of those boxes now. Water land management, environmental monitoring, all the different types of jobs that we've been to within fire and rescue as our normal core roles as fire, hazmat and rescues within that stage, but all the other government agencies that we're doing work for, such as the EPA, Water New South Wales, RMS, you name it, we've just about ticked off everything, and actually done work, as well as some of work for other fire services and that as well. So our standard fleet at the moment, we went down the DJI path, and that was mainly because the parts and accessories are very, you can get them anywhere in Australia. You can get them anywhere in the state. You can get them overseas as well. We do deploy internationally with our urban search and rescue and our disaster assistance response team as well. So we needed a platform that was easily accessible. You can fly the smaller one, the smaller Mavics up to the 600. They all fly the same. All the camera systems work seamlessly, and they're very good with their technology. Their technology moves very, very quickly. But in saying that, also you do have all your eggs in one basket, and we are looking at other types of platforms as well, because if they do fall over, then basically we're grounded. So which happened to one of our Mavic series sort of thing. So on the back of that, it red flagged what we're doing. So we are looking at different types of other platforms that are readily available as well. So at the moment, we've got 75 of the Mavic series. We've just purchased 8 of the new Matrice 30s. We've got 5 Matrice 300s and 4 of the Matrice 600, which is basically our heavy lift capability for our RPAS. So within the 600, it provides our incendiary dropping system that we have connected to that. So basically, like it has small, what they call dragon eggs, full of full of potassium permanganate, and then it's injected with glycol, and then we can actually drop that in a controlled series mapped around the urban interface to actually help with HR burns. Early on in 2019, when we were looking at bushfires, we found, working in the bushfires from 2019, 2020, we found that the helicopters were getting tied up with a lot of menial tasks where they could actually, the crewed aircraft could be utilized for more specific and jobs that were more for them. And we looked into this, and yeah, we've got 3 of the systems now, and they work quite well. With the 600s, as I said, it's our heavy lift. So we use our LiDAR, hyperspectral, multispectral, the ground penetrating radar. They're all flown by our aviation officers. We have within our section a tiered system. So we have a tier 1, 2, and 3, and 4. The tier 1 and 2 are basically our regional stations that are coming online. They have a basic capability and basic mapping capability. The tier 3 and tier 4 goes up into the more high-end side of things, like the hyperspectral, the LiDAR, ground penetrating radar, because there is a little bit around setting up ground-based stations and getting all that data out and then back to our GIS specialists. All the section is located at our Emergency Services Academy located out at Orchard Hills. We go to our 300 series. These are basic workhorses. They're used on day-to-day jobs that we do all the time. Very, very good. The camera systems that you have on these can be swapped out very easily. So there are removable camera sensor payload sensors that provide video, thermal imaging, temperature readouts. The capability on the H20Ts from the old systems that we used to use are far exceeding, and even now this system has been miniaturized. That sits on the new Matrice 30s as well. Very, very good. We can connect our LiDAR. We've got a new LiDAR system coming for these as well, and our hyperspectral. Each of our vehicles carry one of these. So we carry a standard complement in our vehicles that if we turned out today, what we've been doing for the last, since 2019 with the bushfires, and now with all the flood work that we've been doing for the last 2 years, so to speak. As I said, we carry out large mapping areas with these. You can see some of the works that we've done here. Rescue hazmat jobs, mapping of areas impacted by disaster, floods, bushfires, and storms. As I said, attached to each aviation officer. There's not really much now that we haven't been able to map or get that, I suppose, intelligence back to who needs it, whether it's like for a bushfire back to the fire control centers, or if it's mapping the actual floods Now that's that's in the actual rescue phase and rolling on to the recovery phase, as well as the preparedness as well, which we've been doing a lot overseas and in a few different, the Asia Pacific at the moment as well. This is a new Mavic 30. So we had we're lucky enough to trial and test fire these about a week and a half ago. There's only 2 in Australia at the moment. They are IP55. So with most general duties RPAS, they are not very waterproof. So what we've found, the evolution over the last 8 years or so, is they're becoming more weather resistant. This is probably the best one we've seen. There are other RPAS systems that are on the market, but you're paying mil spec money for that. You're paying 250 grand or more for that sort of capability and everything. This is an easy fit for us. So as this technology moves, as I said, and starts evolving, you start getting it. So this is IP55. We flew it in the rain the other day. It worked seamlessly, and it actually flew for 43 minutes, which is probably a game changer as well. You look at most RPASs, they fly for around about the 25 minutes for the smaller units. The bigger units, like the 600s, maybe 40 odd minutes. But this is starting to get up there where we can fly for longer times. And all the different types of camera systems, payload sensors, LiDAR, hyperspectral, multispectral are coming to this, which is pretty exciting. Our little Mavic, the Mavic, so we run the Mavic 2 Enterprise Advances. That's what's rolling out to our regional stations at the moment. We just finished up doing all the training that come out of the business case. So we've got 20 stations that are now dotted throughout New South Wales to give us coverage up to a tier 2, which is basically they'll eye in the sky. They can live stream back to any portable device as long as you've got the login, and we can do basic mapping with like a incident map that's not cloud-based. It's actually like it's for your laptop, and we can usually run out say a 1 hectare map in around about 20 minutes that can be annotated and given to an incident commander. You can overlay like areas, spots, whatever you want, name roads, whatever it may be, and then that can be emailed by PDF to anyone that needs it, as long as you've got connectivity. This is our incendiary system that's been used by our bushfire section as well as our other agencies. We've done a lot of testing and with this, and it was actually used just before the rains hit us last year. So all of our BFOs, any areas around an urban interface that we don't have to use a helicopter, we use this because basically you're looking at a rotary ring is around about $5,500 to, depending on size, $5,500 to $10,000 an hour. We can have this up and running within minutes, and it holds around 400 dragon eggs. So it's a lot of fire we can actually put on the ground. Everything is GPS. We can set up to overlay the map. Gives us heights. You can do autonomous flights with it, or you can actually fly it manually. Very, very good. Being used over in the United States this year and last year, and the California wildfires, and with great success as well.
So has that been used in anger yet, Wally? Like those incendiary drops?
Yeah. So we've used them for all of our. Basically, I think 5 or 6 of our hazard reductions that we used around Sydney, King's School. We used them for Sydney water for a big hectare burn that they were doing, that they did want to put a helicopter on because it was the terrain was a little bit too hazardous for them, and it worked seamlessly. It was really, really good.
And so rural fire service doesn't have this capability?
No.
Okay.
No. So they've got helicopters that drop incendiaries. So we use it a bit more accuracy along our urban interface as it is. And as I said, the cost is quite down. You can't use it on really big jobs, as you're saying. You've got crewed aircraft that are for that. We're just saying is why tie up a helicopter to be used on a small HR burn when you can utilise this, and you can free that helicopter up to go and do bigger burns or to do search and rescues, whatever it may be, sort of thing. What you see on your screen now is our VTOL or power lift. So takes off like a multi-rotor and then transitions into a fixed wing for large area mapping. So when we're doing rapid damage assessments, boundary reviews, or mapping large areas for deployment, plug and play of like up to 7 different sensors, which include LiDAR as well. And we've got 2 of them coming. I was lucky enough to travel overseas I've just come back from Tonga. We actually mapped 5 different islands for Tonga Assist from the volcano eruption and the tsunami that actually hit the island. So we're actually engaged by DFAT to go over there and map some of these islands, and we actually mapped them with a multi-rotor. This would have been a lot quicker and a lot faster as well. And we're having trouble now with some of our the batteries, what we can actually take overseas and what we can't. So this actually fits into that mold very, very, very good. And the capability, everything is DG'd, manifest, and we can get it overseas, packs down really well. And the good thing about it, we could do it probably about 4 times as quicker than what we could do with a multi-rotor. Bigger areas up to 700 hectares in less time, and it flies for around about 90 minutes or more, sort of thing.
And what's the cost difference in that, say, from
you're probably looking at
the fixed wing?
60,000 for a fixed wing. And then the payload sensors, the plug and play payload sensors are then again. So a LiDAR for that, you're looking around about 100K. Any LiDAR that you look for, any LiDAR you look for any, whether it's fixed wing in that size or the multi-rotor, you look around about 80 to 100. So one of the hyperspectral, anything from $200,000 up to $500,000 underneath your RPAS, that probably costs around $20,000. So if you crash it, that's a lot of money. That's it's basically someone's house, I suppose, when you look at it, sort of thing. Yeah, but like everything's covered with insurance and everything like that. And the systems are very safe flying that these days. You know, it's either pilot error or it's had some sort of critical failure. That's why it's falling out of the sky. The slide on your screen now is basically all the new regional stations that are coming online and how they're dotted throughout New South Wales. So this was part of the out of the bushfire inquiry. Fire and Rescue was identified earlier as probably the go-to for RPAS, whereas you look at the RFS and other agencies with their crewed aircraft, they're all over that. So we concentrated on the RPAS side of things. And within Australia, I'd say we're the leaders within our fire department side of things, and that's growing, as I said, exponentially. So basically, we'll have a coverage of all of New South Wales up. So these stations will cover up to around about 150 to 200 kilometre radius. They can interlink with each other. They can do, as I said, between a tier 1 and tier 2 capability to get the initial intel that they need. And then if they need follow-up, then the aviation officers or another team can actually come in and enhance their capability as well, which what we've found with the flood work. So early on with Lismore, after the not the second flood, but the first flood, we're engaged by PWA, EPA, a lot of other services, SCS as well, for doing the rapid damage assessment. So we automatically attach an RPADS unit to the damage assessment teams, and that they are to gather all the intel within that. The public works advisory, we get all the flood level heights. We also do critical infrastructure flights on all the bridges. We were doing sewage treatment plants, water treatment plants, those sorts of things, as well as the LiDAR was doing the mapping for all of the waste that was coming out of people's houses that was going to landfill. And we were actually flying the LiDAR at Alstonville, Coracai, and a few other places that getting volumetric calculations. So we could give that to EPA so they could look at where all that was going into landfill, which we've got another flight that the team's heading up on Tuesday to redo another flight of what that is. So with these stations coming online, we're engaging them when we're doing the high-end stuff to bring them along and also mentor them in the basic low-level mapping, what we call 360 cooler panoramic photographs. So when we are tasked to this, we do 360 panoramic photos. We do a low-level mapping area, and then we do a LiDAR flight. That's all pulled into a report that then is generated and given to the government agency that's needed. It's also filled with all the damage assessments, the critical infrastructure flights and all that as well. So it's a really good polished product that we come up with at the end, that the GIS team pulled together, and then it's then disseminated to which agency needs it, and they pull out the different types of information that they need. Out of the business case, we also designed a new vehicle. So what we found in 2019, 2020, some of the areas that we were going to had no connectivity whatsoever, and we had to use our GSAT system. So on the back of that, the team designed a new vehicle. So the vehicle is self-sufficient for 8 hours. So it can charge all of our batteries. So that's another capability and something that you have to worry about as well, because they fly in batteries. We've got enough batteries to keep flying for around about 3 hours before then you have to start charging controllers and batteries. So this vehicle, without running, will be able to charge all of our systems for up to 8 hours before you need to plug a generator in or just start it up. The other thing that it actually has is the MG90. So it's an actual internet hub, and also it has satellite. So when we drop out of either 3G, 4G or 5G, it automatically links to the SAT systems that's built into it. And then all of our intel that we're sharing via the data via our laptops is automatic uploaded to who it needs to go to. It's also got Bluetooth, just the handpiece radio system, so you don't have to carry 4 different types of radios with you, like whatever the agency you're working for. Our radios, aviation radios, all that. So they're the new Bluetooth ones. You just clip it onto the headpiece onto you. You can walk within around about 100 meters of the vehicle, and you still be able to talk. We got Selfie Go, so that if we're on 3G, 4G, we'll always boost the system up. It's been very well thought of, and our comms people have done a very good job. We've also got the capability of plugging our portable GX satellite systems into it externally as well, or modems, whatever it may be. So you get an added boost to upload the data, because as you can imagine, if we're doing mapping flights, there's a lot of data that has to be uploaded, and satellite is not really designed for that. So we worked on a system how that breaks down and actually streams it seamlessly as well. Also our communications. So if all of our comms drop out, we can actually use the satellite system to actually do press to talk. So firefighter safety is always our biggest thing. They've got winches, they've got everything on them. They're four-wheel drive. We went to instead of a dual cab, we went to an extra cab. It gave us an extra 400 mil to put a lot more of our equipment that we need into our vehicles. And the second one's just rolled off the production line. The other two will be about 2 weeks behind that. So quite good. Situational awareness, like with anything with an RPAS, it just gives you a top view. What you're seeing on the ground, what you see from above is a lot more. As an IC, or if you're wanting those to have a closer look, the RPAS is quite good for that. One of the other things that we found early on in the onset of when we started this was CASA regulations. So I engaged CASA very early on when we started this project to what it is now, and we've got a lot of instruments that allows us to fly where recreational and even commercial operators aren't allowed to. So Class C airspace, we can fly right up to in Mascot's or Sydney's Class C airspace, same as Bankstown. We don't need aerial approvals. That was costing a lot of money to the organisation. We've just been ticked off an EV loss, extended visual line of sight, Class 1 and Class 2. We're looking at beyond visual line of sight as well. There's not much looking at flying over populous areas. Automatic NOTAMs in some of the areas that we're flying, and area approvals above 400 feet where in different types of areas. So a lot of that's been engaged with CASA at the moment. We're working through that, and there's a few things that have been already going backwards and forwards that we ticked off, and that will be coming out in our manuals very, very shortly. So a lot of other agencies have asked how we've done that. I'm quite willing to share how we've gone because there was a lot of hoops that we jumped through early on, and I know how hard it is to get there. And we've done all the hard work. So, and we're just, I suppose, forging ahead where we can to make it a lot easier for other agencies or organisations to go through, not to go through what we've gone through.
I can't tell if I've got it muted.
One of the other capabilities we're adopting is the gas detector. So in our business case, we've got for our hazmat capability, we've actually got a gas detector, which we're doing some testing on in the next few weeks. That will be attached to our M300, and also that's a miniaturized version of that to the M30 as well. Real-time telemetry, so what it's actually sampling, you'll see on the screen that as well. And eventually that will be rolled out to the regional stations. So as we transition and get rid of our older stock and the newer stock comes into place, that capability will be rolled out throughout New South Wales. At the moment, it sits with our hazmat stations. There's a few stations in our hazmat team that's based at the ESA as a trial run to see how it goes, and then we'll look at how that then gets pushed to our retained stations and also our permanent stations. This is just a little video. It's done with one of the Mavics, so it's just a little show of actually how great the units are. This was a train derailment we did up at Nana Glen. Just shows you that you couldn't get to by foot, and just shows you, you know, the damage. We were then streaming this straight back to the IC. That was 30 kilometres away. The only way we could actually get to this point is by rail car from the rail company. Just shows you where where everything was. And then we actually mapped the area with the Pix4D React and got gas detector readings on each of the rail carts. And then we actually pin dropped a lat and long on those. And then that was actually then generated as a report, and then a PDF, and then email to all the relevant organisations. So this is just a small unit. As I said, the Mavic, the Matrice 30 and the Matrice 300. The camera systems on these are a lot better. Standard RGB camera. The newer ones, the Mavic Advances, have a 42 megapixel camera and a thermal camera that's as good as what they class as the H20. So it just gives you a little bit of a bird's eye view of what's going on. As I said, streaming back. Start the capability very small, like the Mavic Advances are around about a $10,000 mark. So, you know, if you're starting something off for your organization, you don't have to pay the big dollars, but you can start off with something small to get that capability. You can see the sheen on the water as well from the flooding, from all the petrol and the diesel that was leaked. So we actually flew down the creek line to see how far it actually got, so we could set up hazmat crews where they had to bund the area as well. You can see it there on the left-hand side of the area as well. So what you don't see from the ground, you'll definitely will be able to see from the air. As I said, the capability with the payload sensors is just unbelievable these days. You can see levels of different, fluid levels of drums with thermal capability nowadays. How far the train stretched back, what was derailed, what wasn't derailed. So we counted back, so they could disconnect from there and then shunt the trains back, so we could start the cleanup. So that's a good little job that we've attended. Just another one. So this is a 10th alarm factory fire at Curry. Just shows you just an overview of what was being streamed back to our incident command bus. So the ops officer, the IC, were making all the decisions where to place appliances, firefighters, you know, your different types of sectors that you put up, Alpha, Bravo, Charlie and Delta, 2 different fires, how they were were going. You conflicted the thermal, what was on fire. Also, the amount of water that was getting pumped into the system. It was an aluminium smelter, but they also were getting rid of all the hand sanitizer. So that all started leaking. Where was that leaking? We worked that out with EPA as well. All of our footage, as I said, is captured and is actually FIAU come up later on, because the owner got up there, one of our pilots got up there very, very quickly, and they used all that footage as part of the investigation as well. And then just speaking on that, as I said, Michael's team, when he was with FIAU, was engaged very early in the piece, and by far their team has flown many, many hours, and by are very good pilots for flying indoors, where you've had a fire that's gone through the roof. They'll bring their RPAS in via the roof, and then can get all the photographs where it's unsafe to send a firefighter or an investigator in. They can capture all that with an RPAS. Very, very technical wise, flying down hallways and everything like that. So we use Michael's team to teach some of our newer people actually how to fly indoors, which is it's a good kudos to them, because they're very, very good pilots. So one of the other things that we're actually looking at is with the new LiDAR systems, and because they're coming so smaller, is the RPAS can actually do autonomous flight. So it will actually map the area itself and come down and then fly. It knows where the walls are and everything like that. So we can actually build then from a fire investigator's point of view, what the actual building looks like on the inside. Now with that, you can actually take it then off the drone, put a handle on it, and you can walk around on the inside, or you then can put it on a vehicle. So we're looking at how that's evolving within the fire investigation, building collapse, all that sort of thing as well. So when we've done flights within tunnels and all that, so they can, without sending a controller, an RPAS pilot in a dangerous area, we could actually use the drone, the RPAS to fly, and it will map it autonomously for us as well. So that's how far we're moving ahead.
Just a couple of questions, Wally. Ray says, hopefully you've done all the hard yards with gas. I think that's more of a statement than a question. And I think you guys certainly have. Andrew from New Zealand says, how does the rotor wash affect the gas sampling? Good question.
Yeah, no, so a very good question. The one you see is actually the probe sits outside the rotor wash. So, and as we move in, because the actual RPASs aren't stringently safe, so we actually, as we're moving into the area, we're actually monitoring for LELs and everything as what it is. So it has a bag sampler as well. So then that could be pulled off and put through our mass spectrometer, through our scientific advisor as well. So the testing seems to be, the first one we're testing is in about a week's time. But what we've seen from it just in the initial testing phase has been very, very good. But once we got it up and running, I'm happy to share the information as it is, because it's something that we've been looking at for a long time.
Yeah. Another one from David. Regarding explosive gas detection capability, I assume that they are aware if the combustion gas detectors types are used, there is a reasonable lag between the gas cloud and the gas reaching the sensor due to the sinter.
Yeah,
I'm not sure what that is. And as you said, also mentions on this also the drone suitable for use in hazardous areas, as there is a lot of potential ignition sources in the drone. Intrinsically safe drones, is that the next phase or next capability?
Probably is. It's, and one of the things that we've engaged DJI. So a lot of the newer technology is basically from firefighters, from other agencies, whether it's law enforcement, firefighting, what they actually want. So they're touting the M30 as an emergency service drone sort of thing. So in its inception, you know, it's going that way. There is a lot of other gas detectors that are on the market at the moment that use laser. So you don't actually have to fly the RPAS into the, it's like basically a hyperspectral analysis that it uses a laser and different wavelengths to pick up what that gas is. So that's another technology that we're looking as part of the hyperspectral that we're looking at. It's 2 different waves. So it has a built-in library. Everything has a chemical signature and within that spectrum, and then the hyperspectral will actually pick that up. So one of the biggest things we're finding, asbestos after a bushfire or flood, when we're mapping the area to actually to locate that as well, and then automatically then we can send our hazmat team, say, okay, that's asbestos area. They can go there and start cleaning up or barrier tape it off, whatever as be. But it's a good question. It's one that we're very aware of. If you fly your RPAS into an area that is not stringently safe, it's going to blow up, and it will blow up the area.
And I can certainly affirm that FIRU does use these drones in those larger incidents inside buildings because of the collapse potential, and certainly saves investigators getting in there, just recording what they can from that. But I must say that certainly it's actually getting harder to get inside buildings, because the technology on the drones actually stops you. If it gets anywhere near an object, the sensors just say, nah, I'm not going any closer because there's a wire hanging down over there. It'll actually stop you now. Whereas before you could actually go around the wire, it'll tell you it was there, beep, 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 and then you've got to go around it. But now it's you've got to have a nice big hole to sort of get into these buildings.
Yeah, it's one of those things where you have an open door and you have to turn the sensors on to get it into the door and then re-engage them so you can actually start flying. The screen, the slide, there's just a hazmat job we had. Same job, just with a thermal capability. You can see the benefits of the hotspots, what was actually still on fire. With this, we could also direct where the hose streams are going, whether it's ladder platforms. Now the ladder platforms actually, our newer ladder platforms within Fire and Rescue actually come with thermal cameras within the cage, so they can actually see where the streams are and whether they're hitting the hotspots and everything and that as well. So capability-wise, the thermal cameras, the dual payloads on all the Mavic series that we have that are all within the regional centres. And then you get the higher ones that are going on the Matrice 30 and the Matrice 300 and also the 600 that we use also. We've done a lot of subterranean fires as well. So we've mapped 3 subterranean fires, one at Kooragang and then more recently the one at Ostermeer, which is this one here. So we actually take a photo and with our thermal camera, our GIS then pulls that into to their computer system. They work their magic. We also ground truth it with temperature spikes. So we'll actually drive spikes into the ground to get temperature readings to give us a bit of an indication also what the temperature is underneath the ground and how far it's actually spread. So we always ground truth what we see in the air with what we see on the ground and that as well. So some of the use case, what you see, Kooragang Island and Ostermeer, what we actually did there with a thermal for subterranean fires. It spits out a very nice little map. As I said, our GIS are the backbone for our mapping, and they can annotate and pull all the data that's needed out. That puts it in a report that's easily read by what organisation or who actually wants it. Once again, this is Ostermeer. You can see the left-hand slide, the thermal version. That's actually where the fire was. It was actually a coal wash fire. So they basically back in the 60s, there was an open creek, and then someone said, "Oh, do you want some fill to fill up your land?" Because they were actually building new buildings, and they said, someone said, "Oh, we can get a whole heap of coal wash for nothing." So they put that in, and then was it about a year and a half ago? One of the residents cut down a tree. They were building a new pool. Instead of using a stump grinder, they decided to have a party and have a little bonfire. And then that bonfire started into the fire basically, and then it was popping up under people's houses, and they actually dug out. It was a large amount. It went down around about, I think, 8 to 9 meters to actually get all the fire, because they're popping up. The tree caught. You can actually see kill the tree because you can see the heat signature within the branches and everything like that. So that's how good. That was one of our old thermal cameras as well. So you can just see how good it was. And basically all the fulcrum lat and longitude were the actual the spikes that we drove into the ground, the heat spikes to actually get the temperature. We've done a lot of overwater missions, both here in Australia and overseas. As I said, I've been very lucky enough to travel with Fire and Rescue. I've been to Solomon Islands and just recently to Tonga. I've been to America as well with my job. We've done a lot of hazmat jobs within fire and rescue within Sydney area and outside Sydney area, and more recently the flood work up in Lismore. So this is the Iron Chieftain that was at Port Kembla. So you can just see this is our older technology. This was with a Inspire 1 with one of the first thermal cameras. So you can see the actual hold was still on fire. We also found as we come over the side of the ship, you can see the superstructure of the actual the ship. The actual bunker fuel had let go, and it was starting to catch on fire as well. So we then started directing the fire tugs of where to put their hose streams along the structure of the ship before they opened the hole to actually start flooding it and everything like that. So it's one of our first jobs that lasted quite a while, and then since then it's just been full steam ahead, I suppose. So this is in the Solomon Islands. They had a bauxite tanker that broke its mooring in a cyclone. It ran aground on one of their heritage listed islands, Ranella Island, and ruptured all the bunker fuel. So all the fuel started streaming out, and then it was a DFAT request that an AMSA deployment. So what we were doing with the RPAS was finding what they call streamers, which are a big blob of bunker fuel that lets go, and then it just you have that stream of crude oil that sits on top of the ocean. So what we were doing is directing the team that had the skimmer that was skimming up all this fuel along the island. So that was living on a ship that they sent from Darwin for 18 days, and then we're flying off the back of that to map the areas and everything like that, as well as the coastline in Solomon. So yeah, it was a good little adventure. So one of the other deployments the team did was actually go to the Greece bushfires. So they went out there and did their damage assessments. So they flew RDA report points was around 6,000 of them, and they mapped 1,617 of damage assessments with the RPAS as well. So our RPAS units are becoming a day-to-day piece of equipment with all of our building impacts or rapid damage assessments, and that's going to also be helped along with our VTOL as well, which will map it a lot quicker. That's the report that was generated for DFAT. We also do 3D mapping as well. So a lot of the Asia Pacific islands now we're going to, as part of a DART deployment or DFAT request, we'll go and map the infrastructure, the critical infrastructures in these cyclone or earthquake prone areas. So when we have teams, whether it's New Zealand or Oz 1 Queensland or Oz 2 New South Wales that deployed to the areas, they already have a base map layer of and where the critical infrastructures are and where to go to straight away, because most of the time they've been wiped out. There's no signage or anything like that. So these are what they used to look like and how we can get to saving people or getting them back to normality as quickly as like what we did within Tonga and that as well. This is one of the Tonga images. So the one on the left-hand side was before the tsunami hit, and then the one after was after the tsunami hit as well. So we were there just to map the area, also to ground truth the asbestos that was on the ground, or whether it was on the ground or still in the buildings, and that as well as part of the the 5-person personnel team that went across. That was all then, we LiDAR mapped it as well to get volumetric calculations. And then that was all generated for the ADF and DFAT as our final report. That deployment was one of the most interesting ones. We went on, I suppose, every sort of a appliance that either the Royal Australian Navy had, the RAF, or the Army. So it was just it was a really good trip. We were looked after very well from both the ADF and also the locals, the local Tongan people and that as well. They're lovely people. Hopefully we can help them get back to a bit of normality straight away. But this is the sort of deployments that we're finding that are happening now, both in Australia, statewide, interstate, and both internationally. It's more of the disaster assistance with the smaller mapping drones, and also LiDAR, and more probably the hyperspectral as well. The other thing that we are looking at is the multi-spec side of things, where you've had a devastation like this. We can fly the multispectral camera over. That will give us a vegetation mapping, and where probably the best way where they should be grown, their vegetables, taro, whatever it may be, so they can have that as well. So we say this is the best site you could use your to start growing your vegetables, as well as complement that with fishing and everything else that they do. Let me see if this is going to work. Yeah, it mightn't work. So I was going to hopefully do the, oh, yeah, it's popped up maybe. So this is a panorama as of 360. So we mapped the area. As you can see, this is Namuka. So this is one of the bigger islands that was hit. This is how we can do a 360. And then
we can't see that, Wally.
You can't?
No, you might have to select a different screen.
I might be able to come back to it. I'll see how it go.
Yeah, we're still on the presentation.
Copy. Let me get out of that. Yes, I think. Yeah. Still can't see it?
Nah, negative.
Okay. Yeah, I just got to try and get out of this. I might have to stop sharing this one.
Yep.
All right. And PowerPoint. Zach, you see that, Michael?
Not yet.
Okay, stand by. I think there's only a couple more slides anyway, which just goes through the contact details of us and everything like that. So I'm happy for that. Yeah. So
okay, no worries.
If you've got any questions or anything like that, I'm happy to take those. With if anyone's got anything.
If you want to just take yourself off mute, if you've got a question for Wally in relation to RPAS. So I was going to say that I reckon initially when RPAS started, it was MFB was really sort of running, or had the highest sort of capability, but certainly now Fire Rescue has sort of taken over in terms of AFAC with the biggest capability. That's correct, isn't it?
Yeah. So we actually, and I'll give kudos where kudos is due. MFB were the pioneers with RPAS. They were the first ones to start this capability up and running, and they were doing it very, very well. They still are doing it very, very well. But I suppose for us, we've been very lucky with the money that the state government's given us, and to where we are. And I suppose the foresight within fire and rescue. So Paul Baxter, I'll give kudos to him, and also the ELT, where they've seen, and also Dave Lewis, where they've seen the foresight where we could take this and keep running with it, and we have. So I would say between us and New South Wales Police, we are very, very well situated, and probably a little bit ahead of some other government agencies and other emergency services. Not far, but enough to keep them on their toes, I suppose.
Where do you see virtual reality sort of coming into it in terms of the goggles and things like that? Do you think that's the future, or that's coming soon, or is it too hard?
Yeah, so that's when you look at I suppose EV loss, so our extended visual line of sight. I really like to push the boundary with the CASA at the moment. So where CASA don't say no, they just say come up with a better way of doing it and a safer way to do it. So if we can come up with that, then that's good. So with our EV loss class 1, the observer is standing right beside you. We can fly up to 1,200 meters. With class 2, we can then start leapfrogging our observers every 1,200 meters. So that way we can then start flying our RPAS a lot further, as long as they've got a visual of what that is. And then you've got beyond visual line of sight is where I could see us heading. The only stipulation with that, I suppose, a bit of a roadblock is the approval for a BB loss takes up to 3 months, sort of thing. For an emergency service, that's probably not in good stand with us. That's why we went down the EV loss path, but not saying that it's not off the table. It's just a little bit out of reach at the moment, so to speak. So yeah, but yeah, look. I'm very happy where Fire and Rescue are. The capability that's coming in the next few months will put us on the world stage again, I suppose, in where we're heading. I really like the next exploring is a proper heavy lift RPAS where you can fly equipment into areas that you don't have to use a helicopter, or you can't tie up a helicopter. So I'm talking, say, anything from 50 to 200 kilos up to 500 kilos worth of weight.
Wow.
So, push the boundaries where we can to start looking at, above, 150, 200K sub kilo weights and all that sort of thing, where that's going to end. There's a couple on the market that are Australian made. I'm looking at other Australian-made RPASs. Always like to give the opportunity to an Australian company. So there's a couple that we're looking at the moment, and how they'll integrate into Fire and Rescue New South Wales as well.
Les has asked the question: any chance of them being used at night? I think that already happens for us, isn't it? Or... Yeah.
So we've got full MV loss, so which is our night visual line of sight. So as part of our REOC and having a commercial license, we have an instrument that's attached to our REOC. The chief remote pilot myself does the training, and then those pilots are allowed to fly at night as well. And in saying that, it's a really good question, Les, because I think flying at night, you don't have all the people coming towards you. The clarity at night with a thermal is a lot clearer and a lot more concise than you get during the day.
Yes. Any other questions from the floor? Very quiet tonight, but that's okay. Righto. Well, I think if there are no other questions, we might. Someone's coming. Got it. Ray, also for doing night and sentry work.
Yes, we can.
Yes,
and it's a lot better as well.
Yeah, I was going to say it's a bit
because we haven't got other aircraft in that area.
Oh, because they can't do it at night.
and
Yeah.
you can actually see where the incendiaries drop. When we drop the incendiaries, we got a thermal camera on our M600, so we can actually view that. We also use the M300 also to watch if the fire hasn't jumped containment lines and it's still within the box that we've dropped all the things. So basically, you might have, if in that case, one's looking after the other, so to speak. So yeah.
And that's a capabilities now. You can do the incendiaries at night now.
Yes. Yep.
Yeah.
No stopping it.
There you go.
That's a really good question too, because people don't see the impact of the smoke at night as well, where a lot of people complain when you start doing HR burns, a lot of smoke and that around. At night, you can have the burn and do it at night, and then by time sunrise comes, it's all done and dusted.
Yeah, good point. Good point. Righto. Here we go. Another one. Do you Aussie investigators, Aussie fire investigators, use drone for fire investigation? FENZ has some interesting policies which tend to make it too difficult. I could see myself putting one up for every job and just a couple of pics. So I know some of our private fire investigators use them. Well, speaking from FIRU's perspective, yes, we do use them. We probably use them every third or fourth job. We're getting it out. If there's damage to the structure overhead, whether it's a house or a factory, we certainly get them out and take that picture, because it just gives such a really good overall picture of the incident. Plus, certainly in a large structure, it can certainly point you in the sort of right direction of either area of origin or greatest fuel load. And certainly at wildfires, bushfires, it's a great tool, because sometimes you can see the run and the V patterns, and you need to be at height to see from the ground. You sort of think you've got an idea, but you get up, as soon as you get up, that overall view, you just go, oh, there you go. You can see what's happened and how it's been formed. So that's certainly what we're doing at the moment, Fire Rescue. But I know that RFS haven't got it at this stage, but certainly, yeah, this race, not RFS. But certainly they call us. The RFS investigators do call upon our FIRU investigators to say, can you give us a hand, or can you fly your drone? And if we can't do that, we certainly ask the aviation team from Wally if we're unavailable or we're doing jobs or our drones are offline to do that for them or for us. The model that the ones we use is the Mavic Pro or Mavic 2, I think we've got in the office now, or the Mavic 3s are coming out, or
no,
the
Mavic 2 Enterprise Advanced is
that's right,
what
yeah.
you guys are. You've also got Michael's team has it's a dual payload, so you've got an RGB camera and a thermal. You also
right.
got the Mavic with the Hasselblad camera as well for your fancy photos that you like getting. So yeah.
I love the photos. And
it's all in the detail as I know, mate. So yeah.
Yeah, and just that overall photo for your report is just the best, because it just shows you all in one hit what the damage has been, and then away you go into your report. Yeah, and Bobby has mentioned there he uses a Mavic Pro 2 from the truck and recently purchased a Mavic Mini SE for work. So yeah, certainly the privates are using them as well. Very good. Well, we've certainly gone over time. There's plenty to talk about. If there's no other questions, I think we'll sort of sum up here. But thanks, Wally, for your time tonight, coming home from work and getting straight online to do presentation to the association. Much appreciated. So thank you for that. Certainly been information, stuff that I didn't know as well. What's the future is and what the capability is and how big it's getting. And I know that you've employed more staff really to manage all that too. It's at Fire Rescue, because it's just getting bigger than Ben-Hur. So thanks to everyone for joining us here tonight. As I've mentioned before, our June Education Night is going to be interactive. Mark Pellegrino was going to say something about it,
I'm here.
he's here. He's here. Okay,
Yeah,
Mark,
so
can you
we've
quickly,
got a very special presentation.
special, very special for June.
It's going to be a good one. We've got Dan Matrikowski from the US. He's actually going to get up at like 3 or 4 in the morning, his time, to do our presentation out at 6 o'clock our time. So he's a good bloke. It's going to be the impacts of ventilation on fire patterns. And as part of this presentation, you're going to have to, well, you don't have to, but you're going to be requested to do an online course. It's for the Fire Safety Research Institute in the US. So you do that course, and obviously you're expected to have the knowledge from that course, so that Dan's going to give a better presentation for us, more advanced with the newer stuff coming in the research that they're doing. So I'll have the flyer out shortly and share it around. I think Forbes, we're making this one free for anyone to attend.
Yeah.
So I'll be advertising it on LinkedIn and that sort of stuff, but you feel free to share it around to anyone that would be interested.
For sure. It'll be on Facebook. We'll put it on our website, and you'll get an email direct, all members as well. So yeah, it should be interesting. Definitely something different we haven't done before. Do a course first, which encourage you to do. Yeah, they've got a whole number of courses, UL, not just this one, but they're very, very good, great information and good training. So look out for that one. Thanks again to Wally for tonight. We'll see you all soon, and stay safe and